So first of all, today's date, yeah, yay, New Year, 1/2/18, right? 1/2/18. And our Common Core standard today is really going to be talking about direct and inverse variations, okay? So if I start right off the bat, y equals kx sure looks like really y equals mx, right? And so we want to remember that the k is really a slope of a straight line. So if it's a direct variation, what we talked about is always goes to the origin, right? Always goes to the origin. And what Megan said is also correct. It's always going to be linear. If it's a direct variation, it always goes to the origin. And I like what Megan said, and we also know it is linear, okay? It's got to be straight. We know linear means straight line, right? Good job, Megan. So then example 1. So first of all, if y varies directly with x, okay, so already we know it's a direct variation, which means we know a couple of things. It says varies directly. We know a couple of things. One, we know for sure it has to have this point right there. Before I do anything, I know this point right here has to be on the graph. It has to go through 0, 0 because it's a direct variation, okay? That helps us a lot in this problem, okay? And then y is 14. Well, y is 14 and x is 3.5. 1, 2, 3.5, and 14 is probably off the page. 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 is way up here. So I know that, the line would look, something like this, but it's off the page. But I can deal with that if I have to, right? So let me go ahead and... But before I did anything, I took what I knew. I knew two things. To graph this line, I knew it had to go through the origin, 0, 0. So I made that one of my points, right? I graphed my other point, and I also knew another thing that was linear straight. So there's my line. Okay, now. So then, if I need an equation to this, okay? So to get the equation, what I probably would want to do is find out what this slope is. Well, if I use my formula, and I actually do have a formula, because the formula was given to us as y equals kx, right? That's our little equation, so I'm going to use that. And use that information because we know that it's a direct variation. I have a y value and I have an x value, don't I? Right? And then I should be able to solve for k, which in a sense is the slope. So let's put the 14 in for the y. Let's put the 3.5 in for the x. That's all I did. We knew it was a direct variation, so I used the formula. I have a y value and an x value. The only thing I don't have is the k, but I can solve for the k pretty darn easily. Let's divide by 3.5, divide by 3.5, and k will equal, that's what calculators were made for, right? I like about calculators. So let's see, clear. So 14 divided by 3.5, I get an answer 4. So the equation, well, we're going to rewrite this as y equals 4x. Okay, I solve for k. To rewrite the equation, I write as y equals whatever the value of k is, which is 4. There you go. And we graphed it. That was easy, okay? Let's look at example 2, okay? Inverse variation, okay? So, inverse variation, here's a little formula for it. If it's an inverse variation, it's something times something equals a number. Something times something equals a number. Like 12, we got all the combinations of 12. Or like 24, I got all the combinations of 24. So, to do this one, if y inversely varies with x, if y is 3, 1, 2, 3, nope, I'm sorry, 2 and 1, 2, 3, there we go. I only have 1 point, that's it, okay? So, if I want to find out the value of k, let's find k. So let's find k. If you don't already know that k is 6, I'm going to prove it to you. If you don't already know k is 6, how do I already know k is 6? Leora, go ahead.
Because x times y and 3 times 2.
There you go, exactly. But you could use your formula, right? So I've got x, y equals k. Well, I have an x value and a y value, right? So I can put my 2 in here, put my 3 in for y, and sure enough, k is 6, right? You guys agree? So then my equation would simply be my x times y equals 6. So it's saying, what times what makes 6? Well, 2 and 3, and how about 3 and 2? What do you think? How about 3 and 2, and what else? How about what else? 6 and 1, 1, 2, 3, 4, 5, 6 and 1, and what else? What else? 1 and 6, 1, 2, 3, 4, 5, 6, and what else? What else? What else? Negative 2, negative 3, negative 3, negative 2, right? Right? Negative 6, 1, 2, 3, 4, 5, 6, negative 1. Negative 1, negative 6, 1, 2, 3, 4, 5, 6. And then what does it look like? It's got those little curvy loopy-loop things, right? All right. Called a hyperbola, not that you guys care, but it is a hyperbola. I'll write that down anyway. I'm going to. This graph is called a hyperbola. Hyperbola. Just in case you're curious, that graph is called a hyperbola. Have you ever heard of that word before?
Hyperbole.
Hyperbole. Well, I bet there's some root. There's got to be a root word meaning the same thing, maybe. Got to be. Okay.
There should be a typo. Is there something with pole that means like curve?
Yeah.
Because we're parabola. and
Bola,
then
yeah.
also, like maybe hyperbole.
It's got to be. We'll have to look it up sometime.
Yeah.
Okay. Example 3. Ready? Let's go back to math. So, So the area of a triangle varies jointly. So here's, when I do these, the first thing I look for these words right here, okay? Okay? The area of a triangle varies jointly as the base and the height. If the area equals 12 and b 6 and h is 4, so it didn't say inversely, did it? I never saw the word inversely at all. So I'm going to set up something like this. What we do know, we're going to have the area of a triangle is equal to, let's see, the base and the height, okay? So the base times the height, but we need some value k here. Now we probably already know what the value of k is, don't you? Anybody? What do you think the value of k is? Huh?
4. Never mind.
K, so what is it?
6 times 8.
It's got to be 1/2. How do you find the area of a triangle? How do you find the area of a triangle?
Because 1/2 base times 8.
Yeah, so we know k is 1/2. I already know the answer. Let's prove it, okay? So let's put in the 12 for area, right? Let's put the 6 in for the b. Let's put the 4 in for the h. Now we know the answer is 1/2, agree? But let's just show it, okay? So then I'll have, so I put in the 6 for the b, put the 4 in for the h, right? So I'm going to have 12 is equal to k times 24, right? I'll divide by 24 and 0.5 or 1/2, and sure enough, we already knew that because we knew how to find the area of the triangle, right? So the area of this darn thing is 1/2, because we know k, base, times height, because I took my 1/2 and I put it right there, didn't I? Even though I already knew the answer. Okay, now, can I use my formula? Sure. So here's my formula. Here's my formula, which we already know. My formula is area is equal to 1/2 base times height, right? We know that formula, right? Don't go yet, so they're saying now, but we'll let them wait. When they say now, they think they want what you need or not. Okay? Okay, now, so let's check it out. So here's my formula, guys. Okay, we just made a formula, even though we knew the formula of the triangle, right? So let's use it. So find b. So if a is 36, put 36 here. We don't know the base, but we know the height is 8. You okay with that? I just set up my formula. Okay, I've made a formula. Okay, and then what I'm going to do is put things in. A is 36. I'm looking for b, and h is 8. Okay, so let's go 36 equals, well, half of 8 is 4. Oh, there we go. And it comes from right there, right?
I know.
Yeah.
I'm just,
It's okay.
this
It's
graphic.
yeah, I know. divide by 4, and what do we get? We get 9. Okay, oh, ignore that too. It's probably my daughter though. Anyway. Okay, keep going. All right, now.
It might be important.
That is. Hold them with Vision Center. Just let it go. Okay. So, example 4, identify the type of variation. So, if I look at this, we've okay, so, okay, looking at the chart. Now we got two types. We've got either our direct or we have our inverse, right? So the first chart, which one is it?
Direct.
You didn't say that with confidence, though. How could you tell?
Because
Because
each one
it's
goes up.
linear.
Okay, are you sure it's linear?
Well, each one goes up.
So we go up by, as we go up by 3, see, as we go up by 5 here, we go up by how much here? So this goes up by 5, and this goes up by what? 15. So if we're, and this one goes up by how much? This one goes up by 2. This goes up by what? So if I did a slope, because right, they'd have to have the same slope to be linear, I'd have to have a 15, I'd have a 15 over 5, or a 6 over 2. What's the slope?
3.
3. Now, are we sure it goes through 0, 0? Well, one of the things we could do, if we are totally lost, totally confused, say, man, I have no clue. I don't see what you're seeing, Mr. Davies. I could graph it, couldn't we? Worst case, let's say we are so lost, we have a clue. Let's just graph it. So I'm at 3, 9. Oh, I'm going to have to graph it over here on a different piece of paper because that's not going to fit. So, all right. 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 24. That's off my page, right? But the slopes are the same, right? And then if I went back 3, how do I know it's the origin? Okay, so well, let's make our formula. Y equals, what's my slope? 3x, right? Would that work? Would that work? If I plugged in 3, I'd get 9. If I plugged in 8, I'd get 24. If I plugged in 10, so yeah, this one is definitely a direct, right? This one's a direct. How about the next one? Do you think it's inverse? Now this one's actually pretty easy to tell. Because what times what? If we multiply what? If we, this times this, what's this time? What's 8 times 4.5? I don't know.
It's 36.
Okay. 36. What's 12 times 3? Yeah. What's 2 times 18? So I know that 4.58 and 12, 3, and 2, 18 all make 36, don't we? So it's got to be inversely. Do you have to go? Oh, okay. Maybe you got somebody waiting for you?
Yeah.
Okay, sorry about that. Inversely proportionate. Okay, last problem. Okay, let's check this one out. Last problem. Okay, the time t that it takes for a group of volunteers to construct a house varies inversely. This makes sense. Nate, I know you. This is right down what your dad does for a living, right? What? Think about this. It's so obvious. I want to build a house. If I do it by myself, it's going to take a long time, right? But if I had a buddy help me, it would take less time. If I had 10 buddies help me, it would take me even less time. But the more people I add, the less time it takes. I'll say it again. If I add more people, it takes less time. So as one goes up, the other goes down, right? If I had a crew of 100, like what was that show they used to do? What was it? The makeover, whatever?
Extreme home makeover?
That's it. Yeah, and they bring in a crew of like 100 people, and they build this house in a weekend or a week, right?
Usually like 4. They take like a long weekend, so maybe like 3 or 4.
Crazy, but they'd have a crew of like 100 people coming in, right? Insane, huh?
There was one where they did like this like crazy mansion. They had 3 people
Yeah. I would say this one is definitely got to be inversely, right? Inversely, you guys agree? It's got to be inversely because the more the people you have, the less hours it takes, okay? So let's check this one out, okay? So the time t that it takes for a group of volunteers to construct a house varies inversely. Okay, so we know that we're going to go t equals k over v, okay? Now where did I get that equation from, okay? Okay, got it from right there in my reading, okay? So I know that the more volunteers I have, the less time it's going to take, okay? So it says if 20 volunteers can build a house in 62.5 hours, so let's do that. Let's put 62.5 here, and let's put 20 here, okay? All right? So I'm just filling it in. I can put 62.5 for the time, 20 for the volunteers. Could I solve for K? Sure. How would you solve for K? Sure, I can solve for K. Multiply that up there. So K is going to equal my 20 times my 62.5. Let's see what I get. All right. Clear, quit. Yep. Clear. Okay, so let's go 20 times 62.5. So I get K to equal 1,250, okay? You know what that means? If you want to build the house in 1 hour, it's going to take 1,250 people. It's a lot of people. But then we'd have the house built in 1 hour. Or is it 1 hour, 1 day? Hours, wow. Okay, so we have an equation. We have an equation, okay? Our equation is this. T equals 1,250 over V. That's our equation, because we know what K is, right? There's our equation. Now let's use our equation, okay? So our equation says, okay, how many would need to build a house in 50 hours? So I put 50 for T. Does that make sense? Put my 50 in for T. 1,250 over V. Now I got to solve for V. Okay, so I just replace things, okay? Now I got to solve for V. So let's multiply by V. You okay with that? So I'll have 50 V equals 1,250, okay? Divide by 50. 1,250 divided by 50, and I get 25. So I need 25 volunteers to get the house built in 50 hours. That's a big crew, really, because like a lot of times, Savannah's gone, doggone it. A lot of times, Savannah, maybe, what does he have? I'll bet he's got a crew of maybe 4 or 5. Right? And that's volunteers, people. Alright, homework. Yeah, homework. Yeah, and we gotta try, right?